we just have to kick off right now. Okay. So guys, welcome again. We are almost coming to the end of this program, of this class. Last week, we started with Starklings, and this week Starkling Exercises, and this week we would run it up, and Gospel would help us run through these exercises. Actually, they're actually very good to learn Cairo 1.0, and you can always do them on your own while he gets to practice them here. So what's for?
All right, thank you, Paul. So, good evening, everyone. It's good to be here. So I think last week my colleague CC he did from starting from 1 to 20 something. So today we'll be starting from enums, the module that talks about enums. So we'd walk from there down to depending on the time, right? If we're able to finish, we'd finish. So here's how it will work. I would share my screen, and while I try to solve, I would try to explain. And I have another screen. A second screen is somewhere where I would, because I have already solved a solved Cairo 1.0 Starkling exercise where I would, so I don't get stuck, right? Because it's very easy to get stuck in things like this. So, but then what I think what you'd get out of this is that I would try to explain as much as possible to the best of my knowledge. So please confirm that you can see my screen, so can go ahead.
Yeah, let's continue. See it.
Okay. Now, just give me a minute. I'm a bit. Which screen am I sharing? It's good. You can see my screen, right?
Yeah.
Good, great. So, the creator of Starklings made an update recently that allowed us to start the exercise from a particular, to start the program from a particular exercise, and that's what I'll be using today. It's not on the main repo, but I got it by cloning the dev branch. So if you do that, you'll be able to, in the normal Starkling, you can't start the program from a particular exercise, but I had to bring this from dev, and it came at a very important moment because he just made the update not long ago, and we're using it today. So so let's go ahead. So let's go in one. So basically, what they are telling us to do here is that they are telling you to define an enum, right? So basically, this particular exercise is supposed to teach you how enums work in Cairo 1. So if you're coming from, let's say, a language like TypeScript, you would know about enums, or better still, a language like Rust, you definitely have seen enums. So what are enums? Enums are basically a way to have variants of a particular thing. So for instance, you might have a question, a yes or no question, and you want to have yes or no, right? So yes or no are variants of the answer, right? And they are limited list of things you would want to have as your answer, right? So you might ask the question, what is the difference between a struct and an enum in terms of the usage? It's just this, right? In a struct, you can literally store any type you like, and you can just say you want to have a list of, let's say, 10 things, right? But most times in enums, you want to have a list of related things that you know that on a normal day, those things will be grouped together for you to choose one among them. So part of it is true or false, yes or no. Let's say you have list of colors in a particular system per se. So here there are different kind of messages. You have quit, you have echoes, you have echo, you have move, you have change color. So to them, what they're trying to tell us that these are a couple of these are just a couple of values that an enum should have to them, right? So what I'm going to do here, so quickly, let's just define it. So we have this. Let's do this and see if it runs. If it's run, good. If it does not run, we'll investigate. So let's just quickly do this. And please, during the course of the call, if there's anything you don't understand, please just call me back and I'll do my best to answer. So the goal is not necessarily to finish. The goal is for you to understand, no matter how far we go, right? The goal is to understand. So let's see, we have errors, right? So that means we didn't get it right. So let's see. Okay. Okay, so now they're telling us that this is not how to define it, right? So let's now try this. So these exercises are public, so you can always go and check it out yourself. But that's why I said the goal of this is not to finish it because these things are online here. But then I want to try to explain as much as I can. So this passed, right? So basically, this is how to define an enum that doesn't take in any value. So you would notice that quit is empty, echo is empty, move is empty, change color is empty. All these values are empty values, right? It doesn't take any type, right? It doesn't take any particular type. So that's that for this particular exercise. So this is just a bare enum. It doesn't really do much, just takes in empty values from the first to the last. So for us to move to the next exercise, I think you probably already know this. We just remove this and we'll move to the next exercise, which is the second one. It's a bit slow. Okay, now we are in the next exercise. So now, based on this implementation, you find out that it's a bit more complex, right? So here they have an array. Using the array trait, we have an array, we create a new array, then you append. So this array is meant to take the message enums, right? So you can have different variants of the message enum as your values in this array. So first off, they've added, so using the append, so this append is a method from the array trait, right? So append here, just all what it does is like just add values to the array, just like maybe push, similar to push, the way push works. So you add the quits, you add echo, you add move, you add change color. You add change color. So from this, what you would understand is that first off, it's not like the last one. The last one we just had bare values, but right now you notice that this is taking an empty tuple. This is taking a string. This is taking a tuple, and this is taking another tuple. So let's try this out and see. And please, if you don't understand, please just draw my attention. I'll do my best to answer. Okay. Let's see. Let's see. You have, so you see here, you have types of uint 32. So it's going to be a tuple of 2u in 32 values. So let's see if this works. Okay, let's see. Fingers crossed. Let's see if this works. Okay, it doesn't work, or it didn't work rather. So let's see what the error is. Okay. Okay. Let me quickly check this out.
I think maybe because you have two brackets at the quit variant. Is it?
Okay, I think
Or we
so.
need
Okay, let's.
to
Sorry, you said?
maybe yeah, there as well.
Yeah, I think you're right. So yeah, so that's the issue, right? So this should work. So this should work. Now, just like the way we did the first one, this is empty. This is a string, right? You know, in Cairo 1, failed 252 can take in you can take in values from
The move option, it would have the square brackets, or
sorry, you said?
if we are passing an array into move or change color, how would the syntax look like? Like, how does an array look like?
I think it will have something like this. Since it's array trace is the type, it will have something like this, I think. But
Oh,
I don't think there's a way for us to find out here, but it will have something like this
okay.
here, or maybe something like this. So actually this instead, I think you should have something like this. Then let's say failed 32, you get, so this is better. I think this is it rather.
All right.
Yeah, something like this. But I haven't tried using arrays in enums before, so I don't know. But we can try it out and see. Good. So I think we have this done. Also, as I do this, you can also be running it on your end. So just this is supposed to be like a code along session, and let's try it out and see. So this works. This works. Yeah. I want this to be a bit interactive, to be honest. So
We're
if you
getting
want
to
to
the hard.
ask, so you want to exactly the hard parts, exactly. You know, these things they just start out like you're just going to play, and all of a sudden you just see things that you just leave it and come back the next day. Yeah, so let's see. We have, okay, this one is a bit complex. We have a struct, we have two structs here. So let's see what we are supposed to do. Okay, create a match expression to process the different variants, blah, 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 blah. So now, another good thing about enums is that it makes it easy to use matching, like matching, right? So for instance, now, if you have a limited option, you have limited options, you can easily create conditional statement around them. So take, for instance, you know that you're only expecting yes or no. You can easily do if yes, do this, if no, do this, right? So that's another way to see enums. Enums since they are variants of a particular thing, you know it's limited. So you can always create logic around them easily, rather than having an infinite number of values I don't even know about, which, yes, there are ways to check for that. But that's matching is a very good, is a place where enums are used really well. You understand? So let's try to solve this. So we have this. So in Cairo 1, traits, in fact, let's say in Rust, because Cairo 1 looks a lot like Rust. In Rust, traits are supposed to be like interfaces, right? So basically, if you're coming from programming languages like TypeScript, you would know of interfaces, or if you're coming from languages like Solidity, you know of interfaces. Interfaces are just a way to have blueprints, right? It's basically saying this is how it should look, and I would enforce it, right? So if you have an interface and you say you want a particular class to look like an interface, then it will throw an error if it doesn't look like it, right? So that's just what you are doing here. They have a trait which contains a set of functions that you should have. So you see, it's not implemented, it's just defined here. It's not implemented, just the names. Now you now have something like a class that is supposed to implement them. So as you can see in this particular implementation of these traits, you have the change color, which is supposed to implement this. You have quit, you have echo, you have move, and lastly, you have process. Sorry. So from the terminology, you would notice that this process function is supposed to help us create these values, right? Or rather, it's supposed to help us, like it's supposed to tell us what to call, because you have change color, you have quit, you have echo, you have move. So what they're telling you here is that this process function, based on the value you're being given, you should know what to use. So if you're given a particular kind of value, you should call this function. If you're given a particular kind of value, you should call this. If you're given a particular kind of value, you should call this, right? So that's just the goal, the whole point of this process function. So we want to be able to know which of these functions to call based on the values you are given. And they say we should use match expression, right? So let's see how to go about that. So let's read that again. Create different message variants, blah, 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 when passing it. Okay, so first off, they've told us that the variant we're working with is this one, which is message, right? So if you go back, this is how the message variant looks like, right? Oh, we actually need to implement it. So okay, let's implement it first, right? So let's see. Okay. Implement message variant type based on their usage below. Okay, so let's see. States. Quit. Okay, okay. So I think based on the previous ones, I think we just need to implement just the way we did here, right? We just need to implement it just the way we did here. Then we can now use it to process this one. So I'll just copy that from the last one. So I'll just bring this one in here. Okay, so now since we have that set, let's now create this one based on that. So this is how matching works. So you have match, use the match keyword. So you say match message, right? And then you can now kind of say, okay, if it's a particular value, do this. If it's a particular value, do this. So now let's see the first value here. The first value here is quit, right? So let's say if the value is quit, which is supposed to be like this, if it's quit, then let's do this. So if it's quit, we'll just quickly call this quit. Okay. So we've done this. So let's check out the next one. Echo. So echo. So if you remember what I said at first, now because of we know that we have a set of values, we can easily just write our logic around them. So we know we have quit, we know we have echo, we know we have move, and we know we have change color, right? So these are variants of message. These are different types of message. You can have quit message, you can have echo message. So we are kind of writing logic based on the values for message, right? So now we have echo. So let's quickly call, okay, let's do this. You know, because of echo takes in a felt value, right? If you notice, it takes in a felt value here, would kind of put in an argument, because we know that if we are getting this back, we are getting this with a value. So we'll just put this here, right? So let's do that. Self dot echo, and we'll just pass in the value here, right? So let's go to the next part, which is move. So I think here is where we actually need this message they gave us here. They said, remember, when passing a tuple as a function argument, you need extra parentheses. So let's just quickly take their advice. So let's say, okay, since this is okay, let me confirm something. Oh, okay. So I think something we didn't do right was this particular function move. Okay, move is supposed to take in this point value, right? So let's just quickly change this to points, not tuple. So let's quickly change this to points. Now let's pass in point here. So remember, these things are kind of arguments, because we know we're expecting them. So as you can see, I gave this S. These values are arbitrary. I can give it A, I can give it B, I can give it C. We just know that we're expecting a value that has a particular type. So it should work when we pass it into this function, because we know what the function will accept. We know that this echo function will accept a felt value. So I can give it any name. I can give it A, right? And when I get that A, I can also pass it to the self value, you understand? So now we know we're expecting points. So we can quickly just do this, self dot move position and passing point. So these values are arbitrary, so that it doesn't confuse. These values are just generated. It's not these values are just generated. It's not a variable or anything. Just give it a name, because we know that we're expecting it. All that matters is the type you get. So let's do this. The last variant is change color. If I'm not mistaken, yes, change color. So let's give this change color. So following what they told us here, because it's a tuple, we would have to pass in another parenthesis. Then we'll give it A, B, C. Remember, these are arbitrary. I can try to give these X, Y, and Z. You get, so okay. Change color. Okay. Yeah, so self dot change color X, Y, Z. So let's pray that it works. Okay, so they're telling us unsupported feature. Oh, okay. So we need to put this here, right? We need to put this here. Okay, would it work? Let's see. Okay. Now this makes sense. So this is supposed to take in Like in as much as this is empty, because it was empty, I just decided to put it just like that, but it doesn't accept that. So you need to put in that empty tuple. You need to put it in there. So we've done this. We've done this. Interesting. So at this point, if you don't understand, please just draw me back so I can
So
explain.
before we proceed, I have a question.
Okay, cool. Go ahead.
I think self is a keyword in Cairo, so could you just touch up on the importance of self? Like it's used only for the functions which are in the implementation, or it has other use cases?
Okay, cool. So now let's go back to like, let's start with general knowledge or something. So if you're coming from Python background, or if you're coming from, let's say, JavaScript background, right? In Python, you have self. In JavaScript, I think you have this, right? So it's more like myself. So in as much as I'm creating things, I still want to, because of you're inside my space, I still want to give you a way to call me back, right? So this self now, with this self, as you can see, with this self, I was able to call quit, because this quit is in this implementation space. So maybe just calling this way, I don't think this would actually work, right? So we need to call the whole thing, then tell it what we need. So we called the implementation, then we now told it we need quit. The same here, we need echo. So basically self is self. Self is, as the name implies, self is this implementation, right? Self is this implementation. And even if you had a variable here, let's say, I don't know, I've not, let's see if this would actually mean something. Let's say we had a variable, let a be equals to 5. I guess this should work. I don't think there's an issue with this. Oh, okay. I think there's an issue with this. But basically, even if you had this kind of thing here, you would just do something like this. You would just do something like self.a. It will still give you, so it's basically you're able to communicate with both the variables, or you can call it attributes. You can communicate with the attributes, and you can also communicate with the methods in that particular implementation. So that's that.
Okay. Also, could I just see your implementation of the first and the second to do as well? I don't know why mine doesn't compile. I might have missed this.
Which one? Which one is that?
Let's look at the enum, and I need to cross check with what I have over here because it's not compiled.
Okay, is it this particular enum 3 or another one?
On line 11, line 10.
This one?
Yeah, it looks okay over there. Maybe. Okay. Now I see what's the problem. My head's.
Okay, cool. So moving forward, let's see the next one. So, like I said, the goal of this is not to finish. The goal is to try to explain as much as possible. So, if you have any issue, just indicate and we'll try to look into it together. So we've moved to the next one, which is options. So where's that? Option 1. So so we have option, which is a very interesting concept, to be honest, because in JavaScript you have things like null, you have things like undefined. In Python, you also have undefined. So the way it rusts, or the way Cairo 1 tends to handle such a situation, is you have something called the option trait. And what the option trait is simply is basically a way to kind of, when you're building a function and you want to return a particular value, but you don't know, you only know, you want to be able to account for cases where you have values and where you don't have values. So this is just Cairo's way of telling you that it's either you have a value or you don't have a value. So it's either you have a value, let's say X, or you have none. You understand? So that's what option is all about. It's actually a trait that can return either some or none, where some is a value, but none is none. None is like null. Null is like undefined, right? So it's just a way of telling you that if you have a function that you don't know, you expect it to return a null value at some point if maybe something happens. Okay, so you can just tell us that we're expecting option. Then whenever we get the option, we can now check if that value is some or none. And now the interesting thing is that some and none, they are both enums. Now I talked about variants at first. They are both enums. So you can easily use them to do, you can easily do matching with these values. You can easily do match whether the value is some and you do something around that, or you try to match whether the value is none. So let's just quickly handle this. So basically, this problem is telling you that okay, let's just read it. Let's just read it. So this function returns how much ice cream there is left in the fridge, right? If it's before 10 p.m., there are 5 pieces left. At 10 p.m., someone eats them all. So basically they are telling we have if it's at a particular point in time, return none, right? So let's see. So let's see how to go about this. So if it's before 10, there's 5 left. So let's say if time of day is less than 22. So basically here they are telling you that they use 24-hour system. That one I'm using 22, right? So they are telling you here 10 p.m. is 22, 12 is the value of 0, and option should gracefully handle cases where time of day is more than this. Complete blah 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 blah. Okay, so now if the time of day is less than 10 o'clock, let's return I think so. Let's return 5. I think this should work. Okay, no, this shouldn't have. Okay. Okay. So this would actually give us an error, but let's just see the error to give us just for our own learning purpose. So next, else if okay. Okay,
So
less than or equal to okay.
but where are you getting some? Or some is inbuilt inside the option trait?
It is supposed to, but like I said, it's going to try an error. I'm going to see the error, but this is what I use right now. But let's run this and see why this is not correct. So let's just see. Okay, so I've changed this. I said if the time of day is equal to 10 or less than 10, we have 5 ice cream remaining. But if it's okay, let me remove this. This is from Cairo 0. This is fine. I don't need to put parentheses. So if I have time of day less than or equal to 23, let's see what to give us. So let's say we have option traits from 0. So 0. Now, there are a lot of things wrong with this. Actually, there are a lot of things wrong with this, but let's just see why. So then else, we want to have none. So let's just see. This would actually fail, but let's see the error would get. Now, the first issue which I'm seeing here, based on the error, is that we're expecting a use size value, but I'm giving it an ordinary value. And now in Cairo, when you just put a number, it just sets the number as felt 2252. So this number currently 5 is felt 252. This value 5 is felt 252, but it's expecting an option of use size. So the way we solve this is to simply do this. We change this to use size. We change this to use size 0. But there's still a problem with this, right? Remember that they told us that if it's before 10, not equal to 10, right? So this is actually wrong. It's supposed to be less than or equal to 9, not equal to 10, right? So that's that. Now, with the last problem, which is the way we call this, Vic was asking whether it's inside of this trait. Actually, it's not inside of this trait. It's inside of this. This is an enum, right? This is an enum, and the reason why it's like this is because it is defined something. Let me just show you how it's defined. That way we are able to pass variable type. So let's just say this is how it's actually defined in the Cairo library. So it's defined something like this, and you have some t, you have some t, and you have none. You have none as this. So inside of Cairo 1, this is how it is defined. That is why you are able to pass it with a variable type. So they don't know the type you're going to pass in, but they just believe that any type you pass in, just replace it with this T. So this is called generics. So if you're coming from TypeScript, you might know what this means. This is called generics. So that's why it's still an enum, but they don't know the type as at the time when they are setting it. So you have to put in the type. So here, they are telling us that they want you to accept use size, right? So just have this in mind. This is just an enum, right? This option is an enum, but this is how it's defined in Cairo library. So so the problem with this is that we are using this option trait instead of option. So let's just quickly clean this up.
So Godspur, in Cairo, the semicolons, what role do they serve? They work like the dot notation. Maybe it could have been option.sum in another language, or what
Sorry,
is their role?
is it this one?
Yeah, no, the double, not the semi. Are they semicolons? Yeah,
This
those
one.
double. Yeah.
I think it works like, yeah, it actually works like the dot notation, but not exactly, because in some cases where you would think it would work, it won't actually work. For instance, here, the one we did last, enum, which is the way we are calling these methods. You might want to assume that this would work, which is this one, but it won't work, right? So it's not really like the dot notation, but it works in some cases like enums. It works in enums, and it also works when you're trying to import things. So if you're trying to import things, it would work, but you won't say it's because in Cairo, dot notation means something else. So if you say it's like dot notation, then it might be confusing. But let's just say it works for enums. It works when you're trying to import things from other libraries. And those are the two I'm sure of, right? So they just work for some types. So let's just go back here and see why this is a problem. So we see have an error. Let's see. Let's see. Okay.
Do we need to convert the felt into a different type?
Okay, I think it has something to do with unwrap. Let me confirm. Oh. Okay, so it's actually, I think this is actually fine. This is what's throwing an error. This one here, we've not worked on this. So fix this. How do you get the value contained in the option? So based on our logic, when you put in 12, okay, when you put in 12, it should give you 5 because 12 is less than 21, which is 9 o'clock, right? But this value is still an option. It is not, it is not of this type. So just the way they did it here, you use this unwrap and you unwrap it, and it should be able to give you a value that matches this. Let's see if this works. Okay, it still doesn't work. So cannot assign to an immutable variable. So let's see where the problem is coming from. Oh, interesting. So the same issue we had here, which is about this use size. This time of day we are getting is also use size, and we are comparing it with a felt 2252 value, as you can see. So the same thing we did here, we still need to do it here. So which is simply use size. So any value you don't annotate like this, you're just telling it that it is felt, and they won't match because you're giving it, you cannot be comparing felt and another value that's totally different, which is use size. So use size is more like saying that you want an unsigned integer, but you don't know the size as at the time when you started. Okay, now we have a different error, which is progress. Let's see. Unsupported feature. Less than equal to. Oh, I think I made a mistake. Okay, we have a mistake here, which is the way we defined it. We find it the other way around. So I think they should work. Good. It works finally. So now let me explain this quickly. So now we have unwrapped, which you might be saying, so this unwrap now is tied to the option trait, right? It's tied to the option trait.
Do we still need to unwrap the value we unwrapped because we converted into use size? It's no longer a felt.
Okay, no. Not really, because the argument you're passing in is use size, right? It's use size you're passing in, but we're comparing it with the felt, which doesn't go. So we need to convert the value we are comparing with to a use size too. So in this whole function, there's nowhere that we are asked to use felt. But when I use this, I was comparing with a felt, which it's not supposed to be that way, right? So that's why I did that. So you don't need to unwrap anything here. Yes, there's a way to convert felt to other types, but not in this case. You get. So as I was saying, this unwrap, the reason why we are using it here is, or rather, the reason why we can use it is because it is kind of tied to the option trait, right? We can use this because it's tied to the option trait. It's a method that we can use because we are using options, right? So if you go into the code, you'd be able to see how it's implemented. Okay, sorry, go ahead.
Oh, it's because the function the value it returns is that inbuilt trait, and that inbuilt trait has the unwrap method on it, right?
I think I'm struggling to understand. So can you repeat? Sorry.
I'm saying we're using unwrap because in our function, the function defined on number 11, we are returning the option, which is an inbuilt trait, and it has that unwrap method, which can work on it.
Yes. So you can, so if you look at this test here, if you look at this test here, they are comparing these two values. And right, if you remove this unwrap, it's more like you're comparing an option enum to an unsigned integer, which doesn't even go together. You understand?
Yeah.
So that's why we are unwrapping it in the first place. That's why this one was actually failing, because they were just comparing these two, this way, which doesn't really make sense, because it's an option and the other one is an unsigned integer. So you can't compare two of them together. They are supposed to be different.
Okay.
Yeah. So let me quickly change something in my VS Code to be able to kind of inspect these things. Just give me a minute. Cairo 1.0. I think I had this. Where did it go to? Okay, let's just leave it for now. I wanted to activate the Cairo 1 extension, so I'll be able to click on this thing and go into the Cairo code, Cairo core code, but maybe I'll do that later. So we've done this, so let's move to the next one. Please, if you have any questions, please ask. Like I said, the goal is to understand, the goal is not to finish it. So it's more helpful when you ask so we can go over it together.
So I have a question.
Okay, go ahead, Vic.
Why do we need to use why does Cairo have the inbuilt option? Why I can't just, because I can also create my enum inside my class, right? Why do we need to use like the option, the specific one they have? Because
option. Okay, go ahead.
Yeah, because I think the way I understand options work like enums. So why is it advisable to use one over the other?
So coming from a Rust background, you would find out that the option is not just an enum. It's an enum that has a lot of methods attached to it, right? So that's one advantage. It's not just like, for instance, if you want to, this unwrap function, the unwrap method we just use is just one of the many methods that it has attached to it. And now it is kind of an agreed standard. It is not like you can implement your own type of option. In fact, there's something else used in Rust, which is the results. It's just like an option, but it's called results. So it returns okay or error, just like option returns some or none. The results enum returns okay or error. It's still the same idea. These things are implemented, so you don't have to implement it yourself. You understand? So if you decide to create your own stuff, it's not bad, but you won't have the support that the one that was given to you has. It's not like you can implement yourself. You can definitely implement yourself, but it's advisable to use theirs, because there are a lot of things that are giving you out of the box that you probably not even think about when you're creating your own. And in the future, you might run into issues where you might need those things and you don't have them. You get?
Okay. Makes sense.
Yeah. So have a new, so let's see what they're saying here. Target, Starklings, option sum, target, option none, simple. Okay, so let's see what they say we should do. Use the sum and its none methods to check if optional targets contains if them below the correct blocks. Interesting. So basically, just like I said before, I said there are many methods tied to this value. So now they're telling us to use these two methods, is sum and is none. So basically from this, you would notice that this is basically a way to check if it's either a sum value or a none value, right? So basically these are just two new, like I said, if you implement it yourself, you probably not put in this. Or maybe you put in this because this is also one of the most popular, but the point is that there are other methods like this that help you even use these things, and it just makes your life easier generally. So basically what they're telling us here is to check if this value they are giving us, whether it's sum or it's none, and we would do different things depending on that. So let's see. So basically they're telling us that, okay, we've taken this value, we're taking if this option target is sum, do this, else if. So we can just do else because there is either none or sum, but just so that we use it, let's just create it like this. So if it's none, we say it is empty. If it's sum, put this, we just do the assertion here. So let's see if this works. Okay, good, it works. It works. So now I might decide to just do this instead. I might decide to just do else because we know we are expecting only 2 values, so we can just do it like that. So it should still run.
So as we are waiting
Great.
for it to run, I have a question.
Okay, go
What's
ahead.
the between using if else and match, which we used earlier?
Yes. So in this case, I was like, okay, let me just use match and we'll now see the difference. In fact, the only reason why I actually use if is because of the say we should use these things. But I think in this case, the best would be to use matching. But let me just show you. I don't think there's more difference. But anytime you're expecting an enum, it is cleaner to use. Anytime you're expecting an enum, it is actually cleaner to use matching than if statement. But in this case, the social use is sum and is none. So that was just like the default. But let's just try this and see how we're going to do this if it was like that. So option. So let's say if it's sum, we have a value, right? So if sum would do this.
Okay.
Yeah, so let's just see if it's sum will do this. Then if it was none, let's see. This should run. Great, it actually runs. So
In our
I think
context,
to
we
me,
felt that we could use those two methods.
yes, you could use any of these, but in this case, they actually said we should use the function. So we just use the ball. If I was the one and I was supposed to build something like this, if once I see an enum, I would just use matching because it's cleaner. Yeah, it's cleaner that way. So let's just clear this out. Let's follow instructions. Okay, it's good. Let's move on to the next. So let's see what they said we should do. Okay, so let's just read this funny. They say don't mind these lines that are required when running recursive functions. So just something to point out. If you want to use recursion, because currently I think this version of Starkling we're currently using doesn't support for loops yet. But yes, there's a version of Cairo that already supports for loops, so nothing to worry about. But there's a version that supports for loop. But right now in this particular implementation, they use recursion. And anytime you're using recursion, you need to add this boilerplate code that just does. In fact, it's just generic. They will need to understand what it does, but basically it takes in this withdraw gas is supposed to return an option, right? So it's supposed to return an option. If it's some, you don't do anything, but if it's none, then you just panic basically. So the panic takes in an array, and basically what it says is out of gas. So it's just some generic code, just in case you were wondering. So what do they say? We should modify the following line so that if there's a grade for the course, it is printed, otherwise prints no grade, right? So the way this currently works is that it uses recursion. So if you notice here, in this particular line, we are calling back the same function. So that makes it recursion, or it's rather that makes it recursive. So let's see, they say we should modify the following line so that if there's a grade for the course, it is printed. Okay. Okay, so basically, I think what I want us to do is, if we have a particular grade, we should print it out, or else we should continue the for loop. Now, the problem with this particular line is that in a situation where you don't have any particular grade, unwrap would actually throw an error, because I don't think when you unwrap none, it will actually give you a meaningful value. It might not throw an error, but I think it would give you an empty value. Understand? So I think that's why this particular thing is important, because you don't want to, if you unwrap none, I don't think you're expecting a meaningful value, right? So that's why we need to do this particular thing here, right? Okay, so let's go ahead. Let's see. So let's use matching. Let's use matching. So let's match course. So first off, let's see what it is supposed to return. Courses at index. Student name. Okay. We append the student name, we append their grades. Then I think this prints. Okay. Okay. Let me just quickly look at my reference so we don't waste much time. Okay. Then we're actually on track. So basically, this is supposed to return an option here. It's supposed to return an option. So let's just write logic based on that. So let's say if it's an option, if it's sum, let's give this X, right? Or let's just say cost rather. Since we are going to return the cost, we just take this one and bring it here. So if it's not, we just continue the loop. Or rather, okay, no, they didn't say we should continue the loop. They said we should print out no grades. So that's fair. So we just simply do this. Okay, we don't have to do this since just modify. Let me remove this. So let's see what the output is. It actually doesn't work. Print not found. Okay. Okay. The issue is here. We're already getting the cost value, so we don't need to unwrap it anymore. Because the only time when you need to unwrap it is if you're getting an option. But if you're getting, once you have this value, you don't need to unwrap. You're having the raw value. So we can just print this out itself. Let's see if this one works. Okay, so print not found on type. This. Identifier not found. Okay, let me remove this. Let's see if this one works. It doesn't still work. Okay. Here's the problem. In Cairo 1, or rather in Cairo generally, you don't use, I think it's because of this. I use double quotes instead of single quotes. All right, let's see if this works. I think if I pull back the parentheses, it should still work. But let's see if this one works. Okay, this works. Let me try putting back the parentheses and see if it works. Oh, it still works. See, so that was not even our issue. So this works. So please, if you have any question, please ask. We are already 1 hour. We already spent 1 hour. Paul, is it supposed to be 1 hour or 2 hours? Let me know when I'm already past the time. Oh, can you hear me?
Yeah, I can hear you.
Okay. So, okay. I guess it's meant to be 2 hours, right? So I don't eat into your time.
1.5.
Okay, so it's 1.5. Oh, okay. So we have little above 20 minutes. So let's see what we can do within this short time. But like I said, the goal is not to finish it. The goal is to understand. So that's why I'm not really, if I wanted to just, actually have the soft parts on another place. So I would have just decided to just giving you, but I want you to understand it rather than just speed up and finish everything, which I wouldn't see how helpful that would be since it's open for everybody to use. So that's why I'm trying to take my time and not just paste the answers for you. So now we have a new concept, arrays. Now they're telling you here that something is not right here. Now, one thing you'd understand is that naturally, by default, values in Cairo are immutable, which is you cannot change them. But if you want to be able to change them, you need to say that you want to be able to change them, unless you won't be able to change them. So you're telling that something has to change here, which is simply just putting mute here. because because here you're actually appending a value, and you can't append a value to an immutable value. So you need to make it mutable to be able to append values onto it. So let's just try this and walk. Okay, so basically we have solved the first one, but now they're telling you that the length needs to be 3. That means basically you need to have 3 values, right? You need to have 3 values. You can't just have 1 value, or else this would fail. So let's just quickly add 2 more values here. Let's say append 2, append 3, then you just return the value. So in Cairo 1, I think you must have, you probably noticed it, that once you have a value like this, you're simply telling the function to return that value. So you don't necessarily have to do this. You don't necessarily have to do this. So you can just have it that way, and you're returning the value that way. So okay, let's see if this works. Okay, I think the first one works, but the next one we're having an issue here. The first element is not 0. Okay, so they want the first element to be 0. So here, as you can see, this is doing pop. So when you say pop front, so they're telling that once you pop the first value, it should give you 0, right? So they're expecting the first value to be 0. So let's just quickly change to 0 and see if this works. So this runs, so this works. This works, right? So basically, we added 3 values. We changed the first value to 0 because we want to pop it and return it. So this works. So let's go to the next. What is it we should do here? Okay, first they're telling you not to modify this function. Oh, when I was actually solving this array was one of the most confusing parts of this Starkling exercises. But fingers crossed, let's see. So if you don't modify this function, okay, it contains one value 42. Okay, to do something to do here. Is there an array method I can use? Okay, remove an element. Okay. Create array. This. Remove this. I think we can use pop. Let's see. I think you can use pop, but let's just see. This dot pop. Let's see if it works. Okay. So actually, based on so this is supposed to be pop front. If you notice, we use pop front here. It was used here. So let's just use it here and see. I think it should work this way. And we don't have to return it. We don't have to return it because it's actually a reference to it. So even if you return it or not, you are modifying it, right? You're modifying the value. So I think this should work. Okay, it works. So if you notice, in this particular function, we didn't return this value A, right? Even based on this function, we are not meant to return any value. But as you can see, you're modifying an array that is outside inside another function, which is, you can call it a side effect if you want to. So basically, you are in an enclosed space, which is the function, and you're modifying things outside. And that, the reason why that's possible because you have a reference to it. You have a reference to it. You're telling you that anything that we do to this value, you should point back to the value that started everything, which is this A. So basically, we are taking this A and we are putting it inside of it, and we are doing things with it and modifying it without returning it. So anything we do inside of here, it will affect this particular one. Sorry. So that's that. So let's move on to the next one. Move on to the next one, which is okay, something to change here. Okay, first off, I think the first thing that comes to mind is the mutable because we don't have that. But I think that's just a bit of, that doesn't solve all our problem. But let's just quickly add that here, since it's the most obvious. I just add mutable there and okay. So modify this method called below to make the test pass. You should not change the index assessed. So let's see. Modify the method called below to make the test pass. Should not change the index. Let me quickly check. Let me check my reference on how this was done.
The test wants us to access a value which is not created.
Yeah. So based on what, okay, let's first understand this particular function, then it will help us solve. The first one was added, the second one was added, and the third one was added. So we have values at index 0, 1, and 2, which is 0, 1, and 2, right? But then this particular value removed the first one, which is this one. So now we now have only two values. So we now have only values at index 0 and index 1. So this value has been removed. So this array actually doesn't create, it creates an array of two values rather than the three values you're seeing here. But here, they're not telling that they want to access the second value, which simply means that it should have three, but you know, the index starts from 0. So once they say that you have three values, once they say you have three values, then you definitely should add one because this value only returns 2. So basically what we should do is simply, let's do a.append, let's say 3, or okay, let's just say 3 since we already have 1 and 2.
So I have a question. How are we still able to refer to the array which has been created inside the other function without using the ref keyword?
Okay, so actually this is actually returned here. It's actually given to us. It's given to us here.
Okay. I follow.
So
okay.
yeah, it's actually given to us here. So that's why we're able to use it. So let's see if this works.
So while still at the ref keyword, so if we can just look back at the previous exercise,
Okay.
the moment we stop using the ref keyword for a particular variable name, it goes out of scope. Now, if we use it again after that, maybe it's like shadowing the initial one. Is it?
Yes. So there's this concept of ownership and borrowing that was gotten from Rust, but this particular scenario doesn't explain it. But then I think it's in this particular part, move semantics, that I would really understand what it's all about. But I don't think so. The basic idea is that if you take a value and you don't return it, you no longer own, like, that value has gone out of scope, just like you said. But this particular case, you're referencing it, right? So you're basically saying that I want to be able to modify this particular value that is at a particular memory address, right? So no matter what you do, you can still modify that value. But if this was, say, if you remove this, if you remove reference, this whole thing won't work, right? Because you're not referencing to that value, right? This particular place would not work. You understand? Except maybe you do this. Let's do this and then return this. Let's see if it actually works. Okay, you don't need to put reference here again. And let's see if this works. Okay, it actually works, because if you notice, did it work? No, I don't know if it actually works.
It shouldn't
Okay,
work, right?
it did not actually work. Yeah, it didn't work. So there's something we're not doing right. But then this is a place that actually help us understand what it's all about. And it's very,
All right.
very, just brace yourself when you get there. A lot of it's actually very confusing, this move semantics. So I think we'd actually use, maybe we'll do like one or two, depending on how fast you go. But it is very interesting. If you can understand it, it's actually very, very helpful. But let's just try and see whether we can reach there today. So okay, it's back on. So we've appended one more value. Okay, 3 actually works. So down to the next one. Oh, struct. Oh, struct is a very interesting topic. Probably the easiest, but let's just see. So we have this particular struct, and here they are using a struct called green, right? So if you're let's say you're a front-end designer, you know about RGB now. Mixture of red, green, and blue, you have a particular color. So that's just the idea. So this is the color struct, right? And each of these values should take in a number. Right? It should actually take in a felt value, right? Okay, it's actually going to take a struct. Let's see. Felt 32 and felt 32. Right, let me quickly check something. Why is it going to take? Okay. I think these are we defined, but that's not the same case here. I was actually thinking this was a tuple because of this, but it's actually just one value we need. Then this is what we are comparing with. So red, green, take in a felt value, blue. Okay, I think we've done this. So now let's actually create it. So this is how these values are created in. This is how structs are created in Cairo 1. We passing this. And I think the order doesn't matter, but let's see. Let's put in blue first before green and see what happens. In rows, the order doesn't matter, but let's see if it matters here. Good, the order doesn't matter, it works. So this is how it is created, and this is how it is defined. You don't have to, the order doesn't matter. I can try to put green first, put red first. It's more like a key value pair. So once you have the key, the order doesn't matter. You can just set it. So far, you put in the value. So this is done. Yeah. This is a bigger one. So let's see. We have this very big struct, name, year, made, blah, blah, blah. So this particular function is going to create a particular struct, and then destructure your order in multiple variables to make the assertion pass. Okay. So if you notice, some of the values here are actually new values. So let's see. Okay, this should be Bob. Okay. Yeah, where's the year? Oh, okay, perfect. So let's create the values, then we'll destructure them just to get these particular values. Okay. So first off, let's see the name. Name is equals to order templates dots name, because this is how to destructure it. We want to be able to get each of these values inside of this struct. You know, this name here, made, they are not defined yet, but we need to get it out of the struct that we already created. So this will be this will be made by phone. Made by email. Made by phone. Made by mobile. What is the difference? Made by mobile. Okay, so we have two more. Number, templates, counts. Okay, let's see. So basically, we destructured it. We just took these individual values from the struct because we know them and we know their names. So we can just easily try to get them out of the struct. So this works. This works. So I think it's almost 1 hour, 30 minutes. So let's just do the last struct. Then would call the day. Okay, so what they say we should do here. Okay. Lights out finally. Okay, so let's see what it is that we should do here. We have sender country, we have receipt, you have weight. Oh, so okay, I remember this. So basically, if it's, if the sender country and the recipient country are different, that means it's an international shipping per se. But if it's not, it is not an international shipping or something, or international package. So let's just do that quickly. So it's international. Let's just write this function to, okay, it's supposed to return a Boolean value here. So let's just do that. So Boolean. So let's just define this. Let's just create this here. Since we have this self already, so if self dot sender country is equal to self dot recipient country, that means we should return is not international. So if they are same, it's not international, else then it's international. So okay. Then in terms of the get fees, basically we are meant to multiply the weight times the price. We're meant to multiply the weight times the price. So okay. Okay, let me quickly put this in Boolean. What should this return? I think she return use size because that's what we're using to compute. So use size. So basically, and now this one, let's go back to arrays. Look at it being used here. So you might say that this is, in as much as this is given to you by Cairo, it's just a normal pattern. Use a new function to create new instances of a particular trait or a particular type. So that what they actually did here. They just use they have a trait called package trait. They have new, which is used to create a particular package. They have this thing to check if it's international. They have a way to get the fees, right? So here you're returning a new. You're returning a new. Sorry, you're creating a new package. Here you're checking if it's international. Here you're getting the fees. Now, basically, what we'll do here is we just get the weight. If you want to get the price, right, you just get the weight, which is weight in grams, multiplied by the cent per gram. So basically, you want to get how much it will cost. So the only thing we need to do is to get how much does the package weigh multiplied by how much we charge per gram. And when we multiply those two values, we're able to get the particular amount of money you're going to pay for your package. So let's see if this works. Okay, it doesn't work. Let's see what our error is. Okay. Okay, I think we have a problem with Okay, this one is meant to return a use size. Use size. I didn't put that. Use size. And I don't think it needs to have a parenthesis. So let's see. Perfect. It works. It works, right? So I think this is a good place to stop because it's already 1 hour 30 minutes, and yeah, please go ahead and ask question in case you've been waiting for us to finish before asking. Please, now is the time to ask before we wrap up.
I have no questions. I've understood
Okay.
the things which are a bit complex or the native or the things which are borrowed from Rust. So those are the ones
Okay.
which I'll have to revisit. But for the arrays and structs, they're a bit more familiar.
Okay, great. Oh, so can someone else? I think no one else have spoken since we started. Does anybody want to ask a question? Please go ahead. Okay, let me just pass the mic to Paul. Paul, you want to say anything? Okay. Think so. We have come to the end of today's session. The video will be uploaded. Okay, go ahead.
Yeah, so I had a question. Do you also have access to the code that you're writing right now, just so we can practice during our free time? Or
Okay, I actually have a repo containing the solved Starkling, but then it kind of helps to kind of go about it without that, but I would definitely share. So okay, I don't want to share it in the main group, so it doesn't seem like I'm just sharing the solution. So send me a message on Telegram and I'll send you that repo. So if you need it. So if I share there, it's more like it's just going there to read it. So but send me a message, I'll share the link to the solved ones I did, and maybe you can go from there. Yeah.
but I personally don't have Telegram as of now. So what other channels would you suggest?
Okay.
Okay.
Can you just share it in the chat here?
Okay. That'll be better. Let me just quickly look for it on GitHub. Give me a minute. Okay. Okay, I have it now. So yeah, so this is it. So these the solved ones. Yes, you can just go ahead. But I would advise you just maybe leave it for a while and try it out before going to it. So
Yeah,
so
sure.
it's yeah, nice.
All right, thank you so much.
Yeah, you're welcome. Okay. Paul, do you want to take it from here?
Yeah. Thank you so much, man. Since we don't have further questions, okay. So we'll be having the week 5, that's the last class before the physical hackathon next week Monday. We have the week 5 class next week Monday. Then at that week 5 class, we'll announce the date for the physical hackathon in Nairobi. Right. So if when we make the announcements, you have every details you need for the physical hackathon, right? So for next week, we would learn how to deploy a complex smart contracts with Cairo, right? So if you are here, also try to show up for the class next week, Monday, same time by 8. Dickens, do you have any other thing to add?
No, nothing to add right now, but yeah, just as you said, the physical hackathon is here. So mine is just to thank Vic and Sharon for showing up and being consistent also.
Yeah, exactly. And everyone that has been showing up as well. So I think that's it for today, and good night, everyone. We'll meet again next week, Monday. And if you have any question, you can always ask in our group chat on Telegram. Okay. So good night.
All right. Good night, guys.
Paul.
Yeah.
Bye.
In the chat yesterday.